Welcome everybody, Mr. Allen here. I'm going to go through a couple of these racing questions from our checkpoint quiz on permutations. I'll just sort of mention a couple of things on one or two of these ones that are here, and then I'll solve one or two as well. So just wording is always going to be tricky in data management, so don't read into things too deeply. So if I look at this first one, it says these 5 people are going to race. How many possible ending scenarios are there if we know that Bob and Emily are the 2 fastest runners in the group? The fact that it says Barb and Emily are the 2 fastest runners in the group, we will assume Barb and Emily finish first and second in some order. Don't sort of interpret that as, well, even though they're the fastest people, maybe somebody else can beat them. It's just, I'm not trying to fool you in any of these questions. Nobody's going to be trying to fool you. We understand that this is the restriction put on things, that these will be the first 2 people, and you'll solve the problem accordingly. Let's see. Similarly here, Barb and Emily had a photo finish in the second example, not necessarily for first place. So photo finish just means they were so close together that nobody could be between, and we couldn't really tell who won, so we had to kind of go to the end line photo gun to really kind of decipher between them. So what that's telling me is that Barb and Emily will be either right in front of each other, or Barb will either be right in front of Emily or right behind Emily, nobody in between. Chris, Don, and Emily finished in the top 3 spots. Should be pretty clear. Obviously, they are there in some order in the first 3 spots, and the other 2 people, I guess Alex and Barb, will be 4th and 5th, or 5th and 4th respectively. Chris and Emily finished back to back, means that basically, again, same sort of thing as Barb and Emily's having a photo finish. Nobody is between them. In this case, though, neither of them is first or last. It means that somebody else will be first, somebody else will be last, and they will be mixed in the 2, 3, 4 spots. And how many possible outcomes if we know that Chris finished just ahead of Emily? So basically the same question again, I guess, except in this case we know Chris is ahead of Emily. Emily did not beat Chris at any point in time. So we'll take a look at 2 of them in particular. As I was explaining those quickly, we realized that several ideas were similar between different questions. And so I'll do one of these ones where we know that Barb and Emily were sort of close together, and then one where we just sort of have some limitations on who can be in different spots. That should cover most of the possibilities. So just as a starting point, anytime I'm setting these up, I tend to kind of give myself locations for the various, whether it's letters, people, numbers, whatever it is. I find that's an easier way to sort of organize my thoughts. So when I'm setting this up, I'm going to think of Barb and Emily as being one item. So I'm going to basically block them off, knowing they have to sort of travel together throughout the question. What that means then is I'm only going to have 4 spots where people can go. So Alex might go here, Chris might go here, Don might go here, or the Barb Emily combo might go here. Same sort of thing here, same sort of thing here, same sort of thing here. So just as I'm going through, I have 4 options here, the 4 I just said, Alex, Chris, Don, or the Barb Emily combo. I'll have 3 options here, 2 options here, 1 option here. Once somebody's been used, or once some item's been used, the Barb Emily item, if you will, has been used, then there are 3 other choices for me, then 2 other choices and 1 other choice. And because I'm looking at an and situation, this has to happen, and this happens, and this happens, my answer will be multiplied. Which means there are 24 ways to sort of organize what I just said. The key, though, is to recognize, of course, I did all that sort of treating Barb Emily as one item, but really that one item could have been Emily Bob as well, and so my answer of 24 will be multiplied by 2 to give me a 48. So there's 48 options in this case. So basically, when I do box off a group like this, I treat it as one item throughout the question, and then after the fact, I want to recognize how many different ways that box can be sorted as well. In this case, I have, sorry, I'm doing this on a tablet. It isn't quite as easy as maybe on a smartboard or something. Oh my goodness, the edge of the tablet is not accurate. So I have my 2 spots here, and so this box can be organized in 2 times 1 ways. Barb or Emily here, the other one here. If there were 3 items in here, then I would have 3 options here, and it would be 3 different ways for the first person to be established, 2 different ways, 1. It would be a 3 factorial at that point. So when we block something off, depending on the number of items, depending on restrictions that may exist in the box itself, it's going to be 2 factorial, 3 factorial, 4 factorial, again, unless there's some sort of organizing that needs to be done in there as well. So second one here, this one should be a little quicker, I think. Chris, Barb, going to race. How many possible outcomes if we know that they finished in the top 3 spots? Okay, so in this case, what I know is I'll still have my 5 finishing positions. But I also know that the group of 3 here are the top 3 finishers, which means that if I just kind of go position by position, there are 3 different people who theoretically could have finished here, either Chris, Dawn, and Emily. Sorry, Chris, Dawn, or Emily. That means 2 of the others, once I've established whoever the winner is, 2 of the other people in this group could potentially be this spot, and then whoever the third person is from that group fills that spot. I don't know anything about the other 2 spots, which means that either Alex or Barb could be here, and the other one would be there. And so this is Chris, Dawn, or Emily. This is here the 2 who remain, and this is the last one in that group, and then here we have Alex or Barb, and then the other one who was not previously chosen. Okay, so that's basically how we go through these questions. Because each one's different, of course, we can't sort of generalize too much. These questions will all be you thinking through what the question tells you and determine how many possibilities for each spot at that point.